A few months ago, Holley reached out to me about installing their Terminator X Max standalone engine management system and harness into my K5 Blazer. I jumped at the opportunity. This is a great option and I think is going to be a great asset to any of those of you out there looking to LS swap your vehicle. I removed my factory PCM that had been running the truck. The factory PCM, TAC module, and harness all came out, and I'm in the process of swapping into the Holley system. I thought I'd take this opportunity to go through some of the electrical challenges that arise when you're doing an LS swap. I know this is intimidating to a lot of you guys out there. It's one of the most common questions I receive when LS swaps come up, but it doesn't need to be that difficult. And today's video is going to show you how to do it, explain the differences between these two systems, and give you guys the information you need to LS swap your vehicle. Today we're talking about the electrical, but I covered a variety of aspects of LS swaps in these videos up here. These are my LS swap video series, and they go into other aspects of the LS swap, what to look for, where to find your engine, things like that. So make sure you have watched those. They will be a good primer for this video and give you the information to make your swap go a lot smoother. If you are not a subscriber to my channel, why the heck not? It doesn't cost a thing. There's a button right there that you can push that will keep you up to date on all the videos I put out. For those of you who want a little bit more, I do have a Patreon page that's going to be linked down below, and I'll put a link up here for that. Why is the electrical component of an LS swap so intimidating to so many people? Well, I think it's because of the giant rat's nest that people see when a project is finished. The reality is, plugging the sensors off of the harness into the appropriate sensors on the engine is simple. Everything is identified, everything is easy to get to, and everything usually is labeled if you buy a harness. That is not the problem. The problem comes from integrating that harness into your factory electrical system. Before we jump into the meat and potatoes, let's bang out a couple of fundamentals that we need to be aware of. 12 volt switched versus 12 volt constant. Those are crucial. Now, the difference being, one is always providing 12 volts to the source that you connect it to, and the other one, as the name implies, only operates when the key is in the switched position. So those two signals are important. The PCM/ECU will require both of those in the system. So identifying them, finding them, and connecting them appropriately is key. Also, grounds. Make sure your grounds are perfect. And I'm not saying just this to give lip service to it. You really do need to pay attention to this. There's a lot of issues that arise if you do not have a good ground. And it is so easy to provide a good ground. Just do it the first time. Take copious amounts of notes about where you want to run things, about voltage draws, about how much amperage is going to be on that particular wire, on where you found the 12 volt switched versus 12 volt constant. Just take lots of notes so you can constantly refer back to them. Use your multimeter. Use your multimeter every chance you get to verify voltage so you know what you're working with and you know if that ground is good. Label as much as you can. As you're going through the harness and you're testing with the multimeter and you're finding your 12 volt switch, your 12 volt constant, or your turn signal wire, or your idle air controller kick down wire, label it. Just take some masking tape, wrap it around, write on it what it is so you know. I know you think you're going to remember because, oh yeah, that's obviously my 12 volt ground. You won't after you've seen another 40 wires. So just take some masking tape, write on it, and put it around the piece of tape. It'll make your life a lot easier. The multimeter is a crucial piece of equipment for an LS swap, but it is not that difficult to use. And all we're going to be doing today is checking voltage with the 12 volt indicator. You're going to take your two probes, your hot will go to your hot, your ground will go to your ground. If you have current This is the best way to determine the quality of the ground you have and the signal that is being pushed through that circuit. Without this tool, you're not going to be able to differentiate between a 12-volt switch, 12-volt ground, and verify grounds, and do all the stuff you need to do. But it's a very, very simple piece of gear. It's very inexpensive. I'll link down below to this particular model and what I've used in the past. But make sure you have one and that you at least know how to use it for the voltage check. When doing an LS swap, the challenge is not going to be how do I plug in the sensors and where do all the harness routings go. No, that's the easy stuff because it's pretty definable. The challenge is, and what I found the most difficult was, where do I find my 12-volt switched, my 12-volt cranking, my relay connections? How do I identify if I've got a good ground? How do I make sure that the circuits are running properly? All the stuff that is basic fundamental electrical stuff, I had to learn the first time I went through doing my LS swap. So I'm going to pass on to you a lot of the tips and tricks that I've picked up along the way that have made my future electrical projects a lot easier and simpler. When you energize the truck's electrical system, you're pushing a latent voltage through everything. Everything that's connected to the truck is going to carry that minor voltage. And that can wreak havoc when it interferes with sensors or it backfeeds the system. And so certain electronic devices, the more specific sensitive electric devices like the switch pros or your controller, your PCM, your computer, those need to have a dedicated 12-volt source, direct to the battery, not to a bus bar, not to a dedicated ground somewhere else. They need to come back to the battery on the negative side and the positive side, because that is where they're going to get clean power that isn't corrupted by background noise or interference from grounds on the frame, power that isn't going to be interferenced by high voltage lines running near it. And essentially you are roping the battery in to do its job of conditioning the power. As it flows through here, it gets conditioned, it gets cleaned up, and so you are delivering a clean 12-volt source to your sensitive electronic devices. Much like it's imperative to have a very good clean ground, it's imperative that you have good energy delivered to your electronics. I hope you guys are sensing a theme here. The objective I have right now is to remove as many problems so that you're not going to be chasing your tail when this guy is installed. There's so many issues that arise because people have poor terminations and poor grounds, and they've got wires that are next to signal wires, that are next to coil wires that just do not provide clean signal. So if we can set it up in the beginning so that you've got good ground, you've got good power, you've got good cable management, the chances of having a problem that you can't find dramatically decrease. The system operates off of a 12-volt signal. Each one of the sensors, whether that's my coolant temperature sensor, my throttle position sensor, my cam position sensor, my oil pressure sensor, those work off usually between 0 and 5 volts. And those sensors will send that particular specific voltage, 4.3 to 4.7 volts, whatever, back to the ECU, which will extrapolate and interpret that data to give you the corresponding values. So you're going to get a voltage signal back from your oil pressure sender, and that's going to interpret, the ECU will interpret that as a numerical value that you can read. That data goes into the ECU, and the computer will determine how much fuel to add, how much fuel to take away, timing, things like that, based on all the sensors that it's reading. It's really simple, it's very robust, and despite all the wires, it's actually a very durable, easy to work on system. Take a lot of notes when you're doing this so you know where things go, you know where they were before you started, and you've got notes backing up what you've done with them during the install. I like to take a lot of my original wiring and label them with just some blue masking tape, or whatever kind of masking, whatever tape, I don't care. But just put on there what it is. So I know that this is my right turn signal. I know that this one is my left turn signal. I know that this is for the KC highlights in my grill. So without having to trace it every time or run the risk of incorrectly wiring it, it's labeled, it's easy. I know where it is. I know what's under the dash. I know where the two wires connect because I've got one at the beginning and one at the end. And it reduces the opportunity to make mistakes. So to make the system fully function, you need to send power to the PCM or ECU from not only the battery, but it's going to need a switched 12-volt source that will deliver power when the key is in the on position. So just to clarify, there's going to be two different sources. There's going to be a switched 12-volt source, which is whenever the key moves into the accessory or run position, and then you'll have a constant 12-volt source also. The constant 12-volt source is going to be always on. You have that so you can maintain time on your clock, and it allows the ECU to boot up faster and things like that. So those are the two things we're going to be looking for, and this is where your multimeter really comes into play, because you can check points on your ignition, points on your fuse panel to see if they have 12 volts during those two different cycles. So right now we can see that on my ignition, I have no voltage in this position, which is what I'm hoping for because that's my 12-volt switched side. So let's give it a charge here. We'll check it again. And there we go. My battery's getting low because I'm running it so much, but I know that this is my 12-volt source. Switched, sorry, because I've got my multimeter onto one of the pins, and then obviously I'm over on the ground also. So you can see right there, low battery, but I do have a constant 12 volts. Turn the key off, and nada. So that is my 12-volt switched source. Your 12-volt constant, you can also find that on your ignition too. I happen to know that mine is over here already, because I've identified it on the ignition switch. If you can get to your ignition switch, you are going to be able to find your 12-volt constant and your 12-volt switched on the terminals on the back of the ignition switch. If you cannot easily access your ignition, you can find the same two things down on your fuse panel. Once again, you're going to require the use of a multimeter to really determine if it is a 12-volt constant or a 12-volt switched circuit. The other piece that you need to be concerned about is your brake pedal. The computer needs to see a brake input for a couple of reasons. First and foremost, it's to release or unlock the torque converter. When you are on the freeway and the torque converter is locked up, when you hit the brakes, that's going to send a signal to the PCM to unlock the torque converter. It's also a neutral safety lockout type thing where it wants to see that your foot is on the brake before it will send ignition to the vehicle. to the computer. And then finally, make sure that you've got a good ground in here. You want to make sure that there's a ground circuit that you can use. I put this little terminal post right up here that all of my grounds come to. Now keep in mind, these do not need to be the sensitive grounds that I was talking about for the ECU or the switch pros, because these are energizing things that are already in the dash. They're ancillary support grounds. But I did still put a nice terminal block in here. Everything's routed and protected. Ran through the firewall up to a bulkhead point on the backside. So there you have it. This is what you're going to be looking for. It's obviously not going to look like this, but fuse panel or ignition are where you are generally going to find the two sources of ignition, 12 volt switched and 12 volt constant, that you need. So while everything's out, let's throw this dash in really quick so I can show you guys just how sweet this is coming together. Once again, this has 12 volt switched and a ground, and my ground goes back to here. My 12 volt switch comes off the ignition, and let's plug this in. I'm not going to plug in the, well, I might as well. Good practice. I've got a GPS speedo, so I don't need to worry about tire sizes or gear ratios or anything like that. It purely has to do with GPS signaling. So let's turn off this light so you guys can see it, and knots on. Now let's go back to accessory. And it should energize. Yep, as does my Switch Pros. That energizes also. It boots up, and I'm good to go. So this is powered in accessory mode. I know it's not powered in constant because obviously it just turned off. Turn to ignition number 1, which would be run, and we're up and going. So it's not all that complicated. There's only 2 types of circuits that you really need to find, and once you find one, you can determine where the source came from and trace it back to the origin if you want to. But make sure that you have your multimeter and you know how to use it. It's critical. You really can't do it without this. In addition to the support of a company like Holley and the harness that comes with it and all the tuning capabilities, the biggest advantage to going with the Holley system over the factory system is going to be the customer experience after the install. You see, when you go with a factory setup, you are constrained to the factory configuration until you can get that PCM tuned for your motor. And if you don't know a tuner, if you don't have someone locally, that can involve mailing your PCM out, waiting for it to come back, putting it in, seeing if it works, sending out again, or if you're lucky, maybe you can email the file back and forth and you could upload it. It was a challenge for me when I did my swap. You also have 2 separate devices. This controls my drive-by-wire, so I don't have a throttle cable. I have a wire to my throttle body, and this is what controlled that. It's more stuff to mount, it's more areas for water and contaminants to get in, it's more wires, and ultimately I can't do anything with it. It's kind of a set it and forget it and hope it works kind of thing. So the fact that the Holley gives me deep dive capability through either the little touchscreen that it comes with, which is right here, I can either use this to tune everything I want to do on the PCM, or I can go through the digital dash that I'm installing. This is huge. Not having to wait for the expertise of somebody else to finish my swap. It's what I want. I really want to understand my electrical system, my automotive system, my shifting system, my battery system. I want to understand everything about my truck, and I could not do that with this guy. The price is comparable. For $1,400, I think it is roughly, the Terminator X Max, Max being drive-by-wire, transmission control, basically the full package, with a harness is like $1,400. If you were to go out and buy a custom-made harness, which I highly recommend if you don't go the Holley route, you're going to be dropping about $1,000 right there, and then at least $300, $400, $500, $600 or more on all the tuning. I really don't understand, and I haven't heard a compelling argument as to why you would go with a factory setup over the Holley system. I see the Holley system just improving as it has self-learning capabilities. So this device is going to be learning how my engine runs, the conditions and expectations I have for it, and constantly refining and changing the fuel table and the timing table. That's massive. So I don't think it could be understated just what an opportunity the Holley system affords you. If you do have smog in your area, which is some of us, if you're dropping an LS and you've got to pass smog, you will need to go with the factory. Unfortunately, there's no way around that. But for everyone else, get that thing out of here and get yourself a Terminator, Terminator X, Terminator X Max, or the Dominator, or the Sniper. I'm going to go into detail on these in a subsequent video, but for right now, this is old school. New school is what's in the truck now, and I cannot wait to fire this thing up. I hope you guys see that this doesn't need to be as difficult as maybe we've built it up in our heads to be. Electrical is very logical, it's simple, it's predictable, and it's easily testable, and you don't get all covered in grease and transmission fluid when you're doing it, unless you're doing it really, really incorrectly. Anyway, I have some other videos that I have prepared for you guys. I'm gonna link them up here. These are the LS swap videos that I linked to earlier in the video. Go check these out. They'll explain a lot of the more basic stuff, acquiring the engine, what to look for, transmission selection, things like that. If you liked what you see, give me a subscribe, give me a comment, and we'll see you next week. Merricks Garage.